Hello, everyone, and welcome to the broadcast. We're getting an early start today. Think we're going to try to cover some interesting ground. We'll see how it works out. Hey there, James. That is not working how it's supposed to. Just a second here. Tweak something. Gotta tweak something. Trying a new chat aggregation thingy. There we go. That might work better. That might work better. Okay. Okay. And there. Okie doke. So one of the things we've done in the interim, the tall one is not running, James, especially early in the day. That has been less populous. I mean, the advertising is good, but we're going to see how it goes without for a little bit. So we changed over to Visual Studio. Because for some reason, Visual Studio Code, it was doing all kinds of weird things, let's say. I don't know what was up with that. So we've moved on to without. Those of you that are in YouTube membership will have gotten a video posted early. But this is where we ended up. James there came up with I think a cleaner way to do the rotation. I'll show you what this rotation is doing in a moment in the code. But there's a lot happening at once, or at least in sequence. So you can see some movement. Well, you can't see it because my head's in the way. But there are a lot of like sub-spirals going on. So this is what's happening. It's default behavior. Right here, the base behavior is to move up, and it does the rotate out, and it will have a spread into 3 during it. So it will start moving, and then it will split into 3 at the end of that motion. Split into 3 only happens once, though. Then, after 3 seconds, we start also moving to the right and rotating out. Now, this move up and rotate out is still happening. Then after 3 seconds, instead of the move right, it now starts to move down and rotate out. So we're always rotating out, and at the end of each one, we split into 3. And then we shift to left. So one of the things we can show is we're only going to add an additional movement here. We're not going to keep the amplified rotate out. Should still have a rotate out. Why are you making me look bad? Oh, because I commented all the rotate outs. So here is the moving up and rotating out. Then we're going to be steadily changing the direction as we go, which further distorts each rotation until it will culminate with we'll check in a moment because I've already forgotten. We've almost got this like vortex going here, heading into my ear apparently. Well, that one looks really good. I like that. See, if you look, it's almost like a tube surrounded by a converging spiral. Now we've got each of the different groups from the various splits spreading out now that we're out of available projectiles. Now what it culminated doing is up and left was the final motion going on. But yeah. So one of the things we need to finish is getting the rotate fully configurable. Let's hop on over to that. Again, the UI is not, let's be frank, the UI is no longer stupid. There was so much bad about the UI in Visual Studio Code. Okay, so these degrees per second, all of this doesn't really matter much anymore. We're still going to try to leverage some of it. Because right now we have our speed. It's this 96. Technically it's 96 times 5 right now to give it some real oomph as far as how fast it moves around the curve. And if we don't have an initial movement, this is a failsafe in case the projectile is not moving at all, or at least doesn't move during the initial. So we'll kind of skew it off a bit. But we're going to be able to get some variations here as far as how it handles that. So we get this initial vector. This is the distance from the projectile to what it perceives to be its center. That is, if it's not set currently, it is set 5 squares left, what we'll call it. And then it's whenever we update, we are moving the center based on the current proposed movement. So we started in the catalog, we're moving up. So the center is moving up with it. This is not going to be end behavior. The center will either hold still most of the time if it starts as a rotation, or it will track a target. But for the most part here, let's clear those out. Can I do this now that we're using a platform that is cleaner here? I think there's a shortcut for this. But what? And sadly, when I've got the I don't need to be pushing that button. Why am I pushing that button? Never mind. Let's not hide it. Oh, well, we'll just do this the straightforward way. So we're going to keep just the basic behavior. And we're just rotating out so that we can see what it does by itself. This is an unmodified rotate out. And one of the things you can see is that the split isn't happening. There is no rotation to the split because by default the rotate out doesn't have any obedience to the other parts of the motion, the other parts of the rotation. So that's going to be something we're going to work on here. And this also isn't set to rotate in. Rotate out. It does rotate in. And that is controlled largely by when we the direction of rotation is determined by how we set up this part of the rotation. And what we're multiplying the speed by. If we do this negative, then we're going to get the reverse. So the orthogonal is always 90 degrees counterclockwise, is what it's claiming to do. And then this rotates clockwise. So we can get different results based on this. So if we put a negative speed in there. Hey there, MP. So we do negative speed, and now we do it counterclockwise. We're working on the finishing up the rotation motion today. Because we've got the negative speed, now we have a wide rotate out. So here is with a negative rotation, we're going around the other way. A little bit of both, So here's a negative rotation with a positive orthogonal. So it should be coming around, yep. Let's tighten this up a little bit so we can see it. They're orbiting a point over here. Oh, more like over here, but you'll see it when it starts to... no, we won't because it's doing a wide arc here. Faster this moves, the wider the arc is going to be. So if these don't match, like if these match, we get inward. If they don't match, we get outward. Isn't that neat? Then, if instead of this, we say, just copy this a moment. And we'll keep it in the center. And now we are going to make this, again, not match. So what we should get is an outward spiral. Was much wider because it was spiraling out from over here and starting here. So gameplay-wise, spiral in would always be accompanied by like targeting, saying like spiral in on that thing. So we have a couple of goals to accomplish. Is we want, like right now, this is supposed to be splitting. Each of these like blobs is actually a cluster of 3. The split does not work with just the rotation itself. And I need some math to make it so that we guarantee a rotate in or a rotate out. And I think we can cleanly do that. I don't mind that it's always counterclockwise. This will control whether it is counterclockwise or not. So again, we're going to keep the spiral out. This should reverse the direction. Yep. And might keep it clockwise. And then in or out is controlled by this one. So we need a couple of things here. One is we need to figure out how to make rotation impacted. And I'm not sure exactly how we want to do that. This one will come into existence. Let's look at some markers, how we're doing this. I think it's the targeting ones that have the most impact from rotation. Let's see. Move. Straight line. Interesting. I'm curious as to how I accomplished this at all. We take the entity we call rotate on it, and then in a behavior, by default, rotate we'll call rotate on a targeter, but do nothing itself. And target direction doesn't deal with a rotate. No, wait, targeter. Here we go, targeter. Okay, by default, rotate on a targeter will update its direction. So we need to make sure that the targeter on the rotates matter. So in targeter here, I'm sorry, rotate. We are going in and we're saying like, all right, we're determining what our 0 point is. Because it can't be this part rotated necessarily. Actually, it could. That would skew the whole rotation, though. That would skew it off target. That's one way it can behave, MP. If it spirals in, it would spiral in on a target. If it spirals out from a target. That target can be a spot. It could be a moving thing like the player. And it also doesn't need to go out or not. And that's one of the things we'll have to mark on it. Because it's kind of like this one right here, I believe, that makes it push outward. Because this orthogonal here is the part that should make it just rotate around that target. So if let's just verify that I'm thinking of this correctly. Okay, so this should be without a spiral effect here, or an outward effect here. Eventually, it will interact with what it hits. Okay, so there is a target out here somewhere. So there's going to be some wobble around the edge based on what the speed is, but we should not get an expanding circle. But we are getting an expanding circle a little bit. Like, it tightens up right here and it's widening out to this side. I don't hate that. I don't hate that. But it is widening out a little bit each time. I suspect it will be influenced by the speed here. At least it should be. So in this case, we are rotating it at the same speed that we were, but the actual object is moving slower. I'm wondering if this will keep it tighter because we don't have as much time to kind of outpace the curve. Yeah, we're still getting some bloat to the edge here. Okay, what if... Okay, fine. Just looking at this to see if there's any further tweaking we have to do. Yeah, the faster it moves, the harder it, like, whips out of the circle. So to get a true orbit, we're going to have to add something to it. But it won't be in spiral itself, in rotate. There's going to have to be an additional force we apply. Otherwise, even without rotating to put it into a faster spiral, we are getting a slow acceleration out of orbit here. It doesn't increase in angle, but it does spiral out. I'm sure there might be something math-wise we could do to restrain it. But let's not bark up that tree for now. Just for giggles. There'd have to be like an inward pressure for it to pull back in. Oh, wait, that's a spiral out. I think that should make it a spiral in. No, that's the counterclockwise part. Okay. So again, if they match, then we have in. If it's the reverse, we have out. Now we need a way to make the split happen. So the split is influenced by the targeter. But how can we get the split to actually happen and still be relevant? Because targeter, aside from an entity... Here, let's show it without the rotate to give you... Well, let's show it with a thing that can split. So this is the same thing, but we're adding an upward force to it. So if you look, there are three. You can see 3 blobs in each group starting to spread out. My cats are dodging, by the way. Forgot to move the other blanket. Let's tighten that rotation so we can see more of it. So the spiral is really slow compared to the rotate is very slow compared to the upward. This is the split. So we're trying to put this on the rotate, because right now the rotate is a velocity applying thing. So it can split. Whereas something like wave by itself does not split because it's a modifying one. Could it? Yes. But we'll get there. For the giggles. Here's zigzagging instead. So more accurate to say that what wave and zigzag do is they take the direction and they twist it. Shotgun spread is something that we can already accomplish. We could have a randomized version of it. Nothing stopping that. At the moment, it's getting the spread in, is the thing. Because this applies a force, we want to be able to have it spread without... Scratched her chin again. Sure, it's not a. Every now and then they'll get some buildup on their chin, but also if they scratch their own chin too intensely, they can get little mini cuts, you know, and it'll scab up and can kind of clog the fur. So got to make sure that that doesn't happen. So again, we want just the rotation to obey a split. This spawner spread 390. It is 3 things at a 90-degree angle across all 3. Speed you up a little bit so we can actually see it. It's outward. Let's put it inward. So the zigzag's influence has a neat little thing going on here. Getting like rounded points. Then if we slow the rotation here. Yeah. Alright, but we want that split to happen. So how do we get this to obey a split? The idea of certain movements that fall next to each other being a combo is interesting. Like these X things consecutively become their own thing when it's actually composing the projectile. In the entity manager, which I put somewhere. Entity manager. We can see the compositing code going on here. So the base behavior gets added or gets put in place. We automatically take that. And that is the first behavior, this new behavior. Until we find a gate, we stuff them all together, which makes it so that if within a gate there is a combo, then we could put an alternate in place of it. There'd be some extra fiddling here, but this is how a bullet is actually created. This would be done beforehand, and then you just copy that creation and put it out into the world. which we could do. We could save a lot of time by composing this during it, because we don't need to keep getting it from the catalog, but that's because this is test code. Anyway. So we have no movement coming into it. We have, is the center set? This is only relevant if the center is not a moving target, is not an entity. So there is if targeter dot entity is not equal null, then we do a thing. Else we do a thing. So this is the else. Going to let's control K. Was it R? Control R, Control R. Yeah, okay. We're going to need to workshop this logic a little bit. But if there's an entity on the targeter, then we have moving target. So center is equal to targeter.entity.position. This is moving target. It doesn't have to move, but the center will follow wherever the entity target is. If not, this is a fixed point target. And we're going to impact that once. Fixed point target will be wherever the projectile currently is. We don't have the idea of target a point on the screen. If we wanted to do that, target a point on the screen would be wherever you put the projectile initially for it to spiral out from, or orbit, or whatever. So initial creation, we get entity.position. Mouse guided will be a additional force. There's targeting the cursor, which is just getting a direction to wherever the cursor is. But move to cursor would be a different thing. What you would do is target cursor, move straight line, and it would apply a force directly towards where the cursor is. In the case of move rotate, either that would drag it potentially away from the entity, or if it was a fixed, a non-entity one, depending on which point you put it at, before or after the rotation, it would either cause the rotate center to move, or it would just drag it in the based on where it currently was. But Put another way, towards cursor is a force and not an adjustment, just like rotate is a force. With zigzag and wave being adjustments. We will get to mouse guided. There's some technical hurdles, like Godot system hurdles, to getting that working properly within the architecture that I am creating. Absolutely possible, just structure. We'll keep that there for testing purposes. So where would the rotation be applied? Now, we could impact like this, that an entity would have its angle increment, and if it's split, that increment is different. Let's start with that. So when we set our angle increment, it's going to be in degrees per second. So we don't need to do that. We're going to say degrees per second, which is our angle increment. In the catalog, when we do move rotate, load movements, we don't need the gates on these anymore. These would not have gates. These are building blocks. They are not the final part, you know? Degrees per second here. Percent change per second is not what we want. This targeter could be something, but it won't have an impact if the center is far away, which means spread, if we rely on the targeter to give us an actual direction, then it won't do anything, let's say. If this gives us an entity, that has an impact, but a direction doesn't really affect all use cases. So rotate out and in. We need to set up multipliers to change that. And see, wave and zigzag do not have really much to them. We do need to have some parameters to wave, though. Anyway. So we have an angle increment being set, and you can make this negative to be a to change the rotation direction. Because this gets tricky. If I pass a negative number into this, it causes it to be counterclockwise. Whether it's in or out depends on if the velocity around the edge is with or against the direction of rotation. So if I'm rotating clockwise and I give it a positive vector, then we'll get inward. But if I give it a negative vector, that's taking that rotation and it's going against it. So in the opposite direction. And that pushes it wider. We get a constant force out of the circle instead of into it, effectively. I think that's how it's working. Let me make sure I'm saying that right. You back. Catalog and make sure our load entity okay, we are just doing the movement. So this should be matching signs. Should be clockwise and in. Oh, I'm sorry. Clockwise. And, oh, yep, there we go. Clockwise and in. So there is a there is a relationship, a sine relationship between speed and angle increment here. Not all behaviors will have speeds, and not all movements in general will have a speed. Eventually, I think I'm going to differentiate between things like wave and zigzag, but for the time being. So that is a real thing. That's not a real thing. That's not a thing anymore. Center matters, and fixed center matters. So we can set and get the speed. The speed is going to be in these units. I will probably come up with some sort of multiplier somewhere so that we can set it up, but that would be at the catalog level. We'll default that. I don't want to default that. Save us pain later if I don't default it. No. Speed. That. Vector 2 is a Godot object. Godot works in floats, not doubles. Everything outside of Godot, Godot's classes works in doubles. Even some of the Godot-related functions like physics process and whatnot work in doubles on the C# side. Okay, so we have a speed, we have our angle increment. This might just be a you know what you're doing thing. Okay. To some extent, inside baseball. Checking. Well, hey there, Duke. Okay, that chat aggregator is not getting Twitch, but that one is. That's unfortunate. Why doesn't it get Twitch? Not recognizing it. Quick bit of stream debug there, but hello, Duke. You are joining us for some game dev. While we contemplate this, let's go to our movement so I can put something on the screen for you. So for rotate out, we are going to have speed to negative 96. For rotate in, it's just going to be 96. And this will be the same with our testing pattern. It's that. I was cleaning up the code base, and part of what the templating wanted to do resulted in this mess happening, where it decided, hey, you like to compress a gigantic blob of variable setting into a single value, right? That's a thing that real people do. Center set. And center move rotate dot center fix center set. This is the kind of thing that concepts like AI assistants are, I think, appropriate for and good for. Is things like IntelliSense suggesting, do you mean to do this? Huh, I broke it. As we set the speed, and we set the angle increment. Yeah. Then the speed times the delta. Targeter doesn't have an entity set, so we're going to go into our entity manager. We're going to say only spawn one entity. Exactly, Duke. There are also a lot of cases where people are concerned about being replaced by AI, and there are some fields where that is the case. But I think we're being really premature even in those cases. Because AI is a black box. Generative AI is a black box. Anytime that it's able to do very specific, reliable things, there's usually guardrails all over it and like coded into it that push it away from a true generative. But even with those, you get scary stuff. And thank you. I appreciate the compliment. We're about to figure out where we're going wrong here. Fix center is not set. Center is now to the left. Fix center is set. Our direction to the center is not 0. So we have to move here is to the left. So then orthogonal, which is a counterclockwise rotation, now has us aiming down. And we multiply that by our speed. Our speed is not set. Well, we know what's wrong now. Where's our continue button? Continue. Just a moment. I gotta check something here. Okay, yeah, we know what's going wrong. Catalog. Wait, do we? We're setting the speed. That should be a thing. Speed is used there. We're defaulting it. Oh, but the copy isn't. The copy isn't. This is necessary. This copy function is vital to everything working right. There we go. We go into our entity manager and unbind that. In our catalog, we are using for our entity rotate out. Let's use in because it's easier to see in. If you're wondering why they pile on top of each other so much, our testing logic is set up such that 4 are created a second, so no matter how fast they move out of the center of the screen, which is denoted by the teeny tiny red dot, if you can see it, they always spawn at the same rate. So if they move slower, they stack on top of each other more quickly. There. So there's our spiral out and in. We have the basics of setting them up. Now we need to get the rotation working. So it doesn't really respect and if we rotate, we call base rotate, and then rotated plus equals radians. Rotated equal to move rotate dot rotated. Okay, so if we rotate it, we're adding that. We have a special variable. Now, one of the things that we can do here is we could add in rotated to our angle increment. So it would rotate faster or slower based on that. We could also apply a rotational force somewhere else, like onto the orthogonal. So let's start with this pattern here. Let's make sure we split them. Oh, we are splitting them. So if we go into the entity manager and we say there can be at most 3 of them. Okay. Then okay, rotate will be set. This one's rotated as 0. Still be viable. I'm not seeing a divergence. Let's all right, now we're getting the divergence. Okay. Unbind the number of them again. For those wondering, 15,000 is the max we can render on screen before we start losing frames per second. Now, we're going to take our base movement and we're going to use move right as our base movement. So with move right, we can already see that. How about we rotate out from center? Yeah, you can get quite a way with node-based. There's a lot of song and dance you can do to mitigate it. As might be apparent, you might be able to see it. I have Canvas renderer here. I do want to revisit using the renderer service to see if I can do this without mesh renderer, because I'm doing some things with mesh renderer that might limit me in the future, and I don't want to deal with that. Okay, we are rotating out from center at a relatively slow speed, so it's going to take it some time before it would diverge. But we can already see 3 prongs to the rotation here. Here, here, and here. And a hypnotic, is it not? Okay, it's starting to diverge a bit. This prong here is having some problems escaping, I think. Oh, that's right, because it is tightened in. Right, so this one is rotating slower. And I think this one one of these is the faster one. So this is one route that we can use to get a split into the spiral. Let's try the other way now. It's back to the way it was. Just so. And instead, we're going to add this. Move.rotated by rotated. As a float. Because we're dealing with a vector 2, and vector 2s want floats. So now we're rotating the direction of movement. definitely wrong. Yeah, that's not quite right. Can't be here. Because we're subsequently rotating it again, and that's not quite right. Oh. Rotate it before the orthogonal. That's still really wrong. I mean, okay, technically it's very right. But it's very much not what we want. This was closer, I think, to what we want. So then in our catalog, if we speed them up, this will make the it spread faster. Yeah, at higher speeds, you can get a much better impression that it has split into 3 different spirals. Yeah. Complete tangent. But on the topic of the music I use on the stream, anybody ever play the what is it called? American McGee's Alice games? Oh, several splits along the way? Yeah, we can do that. We can absolutely do that. It is a. I mean, if you're familiar with American McGee, they were associated with Spawn and also with a lot of kind of 90s era make things dark and gritty. So, you know, Wizard of Oz, but with a savage monster lion and, that kind of thing. The Alice series is Alice in Wonderland, but with that vibe. But canonically, the original events occur, like the light and fluffy version. But Alice has a mental health breakdown after the events that happen, with the idea being that while she is in Wonderland, essentially, a fire breaks out at her house and her family dies. And she doesn't take that well. And you now have a lot darker themes, a lot heavier themes happening, but Alice periodically drops back into Wonderland, into her mind, and her mental state has changed it. But that more somber, like cello music, is the kind of thing that they use in that game a lot. Okay, so now it's splitting multiple times every 3 seconds. We should get a very interesting set of spirals going here. Now, granted, you might only get to see that there's multiple overlapping heavy spirals happening once they start dispersing, because right now it's a swirling vortex of little blue bouncing slimes. And let's see, we just hit about 10,000 slimes. So we spawn one every 4 seconds, and I believe each one will split into something like, let's see. At least 12. We might be getting to 36. No, I'm sorry, like 27. Okay, so that was without movement. So the spirals were not being moved during that. They radiated out from the center entirely. So now it's going to start radiating out from the center, and it will always radiate out from the center. So we're going to go to the right, we're going to go down and left. And we'll use this as... We're going to keep this without touching it. So we're actually going to do this again. This one will be up. Our goal, Camphor, is to create a Vampire Survivors style game. A bullet heaven. But the gimmick of it is customizable, like on-the-fly built weaponry. Right now, we're testing rotational movement. Okay, so starting in 3 seconds, the spirals are going to start shifting over time. So we're going to get a very different series of motions happening here. So after 3 seconds, the spiral starts moving up. After another 3 seconds, it starts moving right, then down, then left. But it's always spiraling out from center. So you can see that there's a bit of a oblong shape going on here. If you manage to reach a point like this in the game, pretty much anything is an ultimate ability. Is again, we are creating each projectile, each time a blob is created under this kind of pattern, it would be 3 to the 5th blobs are actually being created. Or, entities. So let's see, that would be 81. So right now, 4 times a second, we are creating a blob, and that blob will eventually become 81 blobs. So if we remove this one, just so, and then we put the rightward vector in here. So the spiral always goes to the right. But there are other motions that start to interfere every 3 seconds. There is an up, another right, and then finally a down that happen. But always to the right, always to the right. Which is why they're converging mostly on the right side of the screen. But eventually, the spirals are being pulled down and right. And they move towards their center. I'm sorry, no, they radiate out from their center. So we should start seeing it break apart, and you'll get to see them tail off. Isn't that neat? We can actually do the same thing with rotate in. That can create some very interesting patterns in and of itself. Done something unexpected. Really didn't expect this. I mean, it looks really cool, but it's not supposed to do this. Yeah, it does look like the ending animation of the old classic solitaire games on, like, PCs. Interesting. Why are they all radiating out like that? Oh, I do have a potential idea there. Try that again. So it all culminates in leftward motion. So you can see that these blobs at the top there are closing in on an orbit, but they're chasing something that is going to the left. This particular split is one of the ones that got a tighter orbit to start with. So it's still chasing to the left at a tighter orbit. It'll be interesting once we see this start to break apart. Because you can see some of them are chasing a target that's moving. Again, they're split and they have still wider target angles. What if they go way faster? And double it. So each of these is a 16 by 16 sprite. The screen is 1080. So it's zoomed in 6 times in order to get them to look this big. The unit of movement as a result, the size of a sprite on screen is actually 96 pixels. And what that is, for our purposes, that represents 1 block So the spirals, the blobs on a spiral edge, are by default moving at currently 10 blob sizes per second. They are being pushed in different directions at 1 blob size per second. Huh. All right, that's with just directions changing with just 1 spiral. We've gotten sidetracked, but I feel like just talking through what we've got. So again, this is base behavior. Base behavior always happens. These are subsequent behaviors. Subsequent behaviors happen in sequence. So execute the base behavior and then execute the current secondary behavior, the currently active one. So this gate says wait 3 seconds before this one becomes active. Once it does, there is another one that says wait 3 seconds before this next one becomes the active one, and so on. So if we then add more spirals, now we can see some additional behavior going on here. There is effectively a second rotate in happening. So we can see almost like curlicue motions going on down here. Both of those spirals can cause it so that it will move so fast along the arc that it needs to course correct harder. Oh, well, that doesn't help. They're all rotate outs. Except for the master rotate in. Alright. All of them rotate outs. Kind of hard to look at, isn't it? Let's slow them back down here. Let's slow them down more. Yeah, making the splits obey the spirals obey the splits has really created some interesting patterns going on here. Especially these on the left there. All right, one more. One more, let's mess around. Okay, moving to the right, rotating out. Then rotate outs Those matter more each time. Up, right, down. Things. So this is one rotate out, but it's influenced by several different directions going on. So you can see they're much more ordered in this scenario. Hey, May, it's moving along. It's moving along. And one. Yeah, there we go. If I go back over here, messing with some stream settings just a moment here. There we go. But welcome, May, welcome. We are making some headway. We are making some headway. Yeah, get some interesting motion going on now. We'll call it down just to some base behaviors so that you can really see it. Going pretty well, May. It's going pretty well today. We started early. We will see how things play out, you know? Alright, we have a zigzag motion in there. That should be lots of fun. So rightward, orbit out, zigzagging. Okay. So rotate in with moving targets makes for interesting patterns. I think we're missing something, though. Because it's like these are chasing things in the wrong direction. How long have I streamed on Twitch? I started up again within, like, the past year, and before that, a few years. My primary channel is on YouTube, but I simulcast. Yeah, it should not be, like, it should be convergent, is the thing. But this is still maintaining its general direction here. That might be the move right taking some precedence. To verify that we're still operating correctly here. A lot of achieving these things has been just messing with it. Like I've told folks, I'm moving pretty slowly on this project because we're simultaneously learning how to do these things. I'm getting sidetracked. I primarily do it on stream, all kinds of stuff like that. I have started working on it more off stream just to keep momentum. So we are seeing some correctness with the spiral out. That's still okay. Is it the extra ones of these distorting it further? The number's flying up because we're getting like 81 4 times a second instead of waiting 3 in between each one. So we should get a slightly different pattern going on because that extra 45 degrees is being applied 5 times. It's an interesting result. Anything that can create multiple projectiles is it's not going to appear terribly commonly because of this kind of thing. Split into 3 or split into 5 just by itself is gonna be a rarer thing. As in, if it does that, then it might not have many other benefits stacked together. It'll take up a whole slot by itself because it multiplies the projectiles. Yeah, we get kind of a neat pattern going with this. We can get extra weird things on this same front if we... So zigzagging won't affect the spread, really. But... we're going to move zigzagging to the end. This is what I've been calling blended motion. This is sequential motion, where the way it moves changes at intervals or over time. This is blended motion, where all of the different types of motion are being mushed together. Which you can get very different results doing that. So the reason I'm interleaving these, one, for the laughs, to see what happens. But additionally, no, this actually won't make a difference. Because these affect, the spreads affect the, how would I put this? The spreads are a global effect. Like, when these happen, doesn't really impact the original. The other ones will be impacted once they spring into existence. But it won't change the way the movement happens. we do to make something interesting happen? Hmm. Oh, that's interesting. We would need a target entity to do one of the things I'm thinking, and that's have something that spirals way out and then after a period of time spirals in. But that won't work if there isn't an entity target, because otherwise spiral in says wherever I am is the center. We could kind of fake it if we do a lot of this. Hello there, Iconic. Let's use wave motion. We are working on our game. We're testing some behaviors here. So what this is going to do is the little blobby things are going to start moving outward from a central point. We are going to go into the rotate behavior, and instead of setting the center at its current position, we are going to temporarily set it to 0, 0. What this will mean is that it's going to go outward for several seconds. It's going to go outward for 9 seconds, and then it's going to try to come back in. It needs to move faster if we're going to see this happen. So outward with wave motion for a while, and then it will eventually come back in. Or, well, it will try to. Because after the 12-second mark, or the 9-second mark, it is now a spiral in fighting with a spiral out. So we're getting these little... we start to get these little corkscrews instead of wide motions. So if instead... Hello, Ember. Ember has come to sit with me. So right here we've got rotate out. If instead of rotate out happening here, are going to have... like I mentioned earlier, MP, I think I mentioned this earlier, moving towards the cursor is going to require a little bit of architecture. Maybe we'll try that next. So we've got to fiddle with this a little bit to make it do what we want. Wave motion. So there is, if you look, there's no base behavior here. After 3 seconds, that's where we're going to split into 81 projectiles. And we are going to start rotating out. Then we're going to add a few of these. Let's see here. That's 9 seconds. 12 seconds. Let's do a nice clean 15. So waits 3. Now it starts spiraling out. Oh, I know what's happening. All right, we need a different gate here. Real quickly, gotta check something. Okay. Had to check something. Good rule of thumb, folks. Good rule of thumb. If a person comes into chat and the first thing that, one of the few things that they say, or one of the initial things they say is, hey, can you say X? On average, most commonly, X is a bad thing to say. You know, sometimes it's something like pseudo benign, like, you know, say happy birthday to my sister or something like that, but you want me to think you're not trustworthy? Do stuff like that. What type of game do I like? Is that a choice between those or just a general question? There we go. Okay, so we've added a wait 15 game. If it's in general the kind of games I like, if I had infinite time to play them, I like narrative games. I like narrative games with strange or interesting worlds to them. Like the Shin Megami Tensei games are really good for that. There are usually aspects to the world that are revealed that create a cool setting, and they tend to be story heavy. But I don't have infinite time, so those can eat up, a chunk of what I can do. One second. Let me look for the kitties here. They're being very evasive today. Oh, wow. A double up in the tree. Let's look closer. If you're saying between fighting or story, then story, absolutely. I'm not a fan of fighting games. Yeah, we can see Sammy and Sky up there. Okay, so we added wait 15. So now if we go into our entity, we're going to wait 15. Sorry, we're going to wait 3. We are going to start moving. Actually, I have a good idea. Another one here. Wait 0. This is a false gate. It does not actually gate. It opens almost immediately. It is something that will be used almost entirely in testing. So again, it starts. It does nothing by default. This is important because we don't want any sort of motion happening by itself. Otherwise, that motion will always occur. Then, after 0 seconds, it begins spiraling out. After 15 seconds, it will spiral in. I kind of like that. Kind of like that. Let's check how we're doing that. Look at this one more time. Spiraling out counterclockwise. I just want to see the difference with this. So it's out clockwise, then it should be in clockwise. Neat. Very neat. I mean, I'm spending a lot of time messing around today, but I feel like it's that kind of day. Move in a random direction. They're going to spread out pretty randomly here. And then they'll start circling back in. I feel like we can do better than this, though. This gets created for each entity that comes into existence, and it's going to be duplicated. So all of this gets copied. Its direction is going to have been set because it's a duplicate of its sibling. Then we're going to apply rotation to it, which will alter the direction. But I think it's this thing that's skewing it. Well, thanks for swinging by, May. I appreciate it. Go into the entity. An entity is rotated. We call rotate on the base behavior. Let's do target direction. To target direction. Rotated radiance. Because target direction is a way that targeters will kind of progress along the line. We're still getting a lot of clustering here. Yeah. I think that should still be there, though. Okay. Okay. We can do this. Okay. This weight 15 is going to be the first in a bunch of split threes here. And then there will be a weight 0 at the end that does the actual spiral in. Again, this is not an actual thing that we're planning to have in the game. So we have move random direction. For 15 seconds. Then we have a weight 15, which will do an initial split into 3. And then a weight 0 that does another split into 3. That's the 3rd, the 4th, the 5th. Let's see what this do. Okay, so 4 blobs a second for 15 seconds in the lifespan of a blob. At that 15 seconds, that blob is going to explode. These masses of them that just popped into existence. I like it. I like it. Sort of vacuum into the center. Now, in an actual gameplay sense, longer term, any sort of bullet that you fire will have a lifespan. Nothing will be infinite. So, 15 seconds is a pretty healthy time for a bullet to live. 1 minute would be a very long time for a bullet to live. But we can do that kind of thing. So, I guess while we're on the topic here, this is spread, and we hard-coded this. So this is a good opportunity to de-hard code it. Count will do nothing if you have that. So again, this needs to be, you need to configure this. Okay, so we create it, it's copyable, great. So if we go into it, we have an angle value that we're going to create them at. So first we need to determine how to get the spread. We did this previously in Godot land, we're now going to recreate it in C# land. Let's see. Initially copy it, let's configure. Interesting. Please stop trying to make single line functions. Set angle. Hey there, Salvatore. We need to be able to set count. We need to be able to set angle. We are going to do a recalculate now. We're doing some math now. All right, all right. It's not a protected. We would want an internal one then. How are we going to do this pattern? We can do set. So we need to recalculate it because we don't want to do the math to determine what the angle spread between the two is. For example, this is 3 with a spread of 90. So throughout the math, what we're going to determine is that 45 degrees is my angle increment, and that I must spawn 2 more, one of which will be 45 and the other one will be negative 45. We are going to enforce that count is at least 3. So if you set it to less than 3, it's going to be 3. If you set it to 4, it's going to be 5. Well, no, tell a lie. We can do it without that. But for the purposes of the way this works, unless it is a 360-degree arc, it's going to be cleanest if it is an odd number. So I think we're going to have to we'll have a failure case. We'll have a failure case. Well, a failover case if there's leftover. If there is an extra projectile, then we'll have a leftover case. So I don't want to recalculate multiple times. Let's put a failsafe here. we do. How we do. So we want to do that. And we can copy over the internal value for the actual angle increment. So we're setting the angle, the arc angle there. And that's how the increment of the angle. When we're copying it, then we can recalculate here. So when we duplicate it, everything has to be correct. So this, by its nature, is correct. Then when we are setting them up, every time you change it, we should recalculate. Ideally, we would not recalculate during the configuration twice. But we can get away with it by setting... Oh, no, we can just have one function. Not pretty, but... There we go. Angle is equal to arc degrees, but it will actually be math f dot degrees to radians, which will return a float. Ugh. Which will still work. We're messing with precision here, but... All right, so now we need to come up with how many left and how many right to spawn. See, some good IntelliSense there. That spawned, count arc angle and angle increment, and then left count, right count. Okay, so left count and right count are how many we're going to go in each direction. So again, in the case of 3, left count and right count will be 1. Spawn is equal to count minus 1. So if count is 1, it's going to be 0. We short circuit all of this. If we have nothing, then left count is equal to 0, right count is equal to 0. So if I have nothing to spawn, if there's only one, we're going to do nothing when that triggers. Has spawned will result in nothing changing. Else. All right, we're doing the division twice. Wasteful doesn't matter. More concise. Spawn minus left count plus right count. Okay, so this will only ever be 0 or 1. So it will favor essentially the left side of a spread. If if the spread is going to the right, it will favor the top. Might end up favoring the bottom. It's going to depend on which order we go in. But for the time being, we're going to say the top or the left or the bottom based on which way you're facing, you know. Full increment is equal to... All right, if we are splitting it into 5, then it will be arc angle divided by 2 spawn. So if we're only spawning 2, then left and right are 45 degrees. If we're spawning 5 of them, there are now... I'm sorry, if the count is 5, then we're spawning 4. And the increment in a 90-degree spread would be 12.5? No. Math. 22.5, I think. Maybe? Yeah. So then... plus... do the same thing for right count. Hello, Sky. You have food, so that's not the issue. times angle increment. All right. So now we do a quick test here with go into our catalog and we're going to load spawners and arc angle. Values, which is it's going to be 3 at 90. Then when we load our entities, I'm just going to simplify this great big mess we created here. We are going to move right. Are going to spawn spread. Want to verify we haven't broken this. Oh, we broke that. What? What? It says pet me. So in load entities, we're adding spawner spread 390. Oh. Oops. And that's not doing what it's supposed to do. Okay, to spawn is now 2. Right and left count are 0. To spawn is greater than 0. Well, I'm contending with Sky here. check on the other kitties. Count and write count should give me 1 each. Okay. Oh. We don't need a degrees to radians it. It's already radians at this point. That was resulting in practically no rotation at all. Come here. Come here, Sky. Over here. Breakpoints. Go. All right. So that's 3. Make it 5. Well, that's not right at all. Because I left out a critical part of the spread logic. And that is that I'm not multiplying times this. I could fix this by just having 1 less than or equal to. Then I can just use I there. This guy is interfering with typing. Here's a 5 spread in 90 degrees. Then we can go back into catalog. And so that's 5 and 90. Let's look at 5 and 360. This is not correct. We're getting a double up at -90. Should be 80 degrees that we're getting out of that. No, that's 90 degrees. That's not correct. No, it would be 180 degrees that it starts with. I have 2 to spawn. Why that math no work? So we have 4 to spawn. We have 360 degrees divided by 4. So we've got 90 degrees that we're working with, which isn't correct. Should have 5 equal segments in that case. 360 degrees is a little different. Especially with odd numbers. Because if I were to put it at 180, we should get the correct result, which would be 45 degrees. Again, 45 degrees. And we'd have in units of 2, so it'd be 45 and 90. So you'd have middle and up. But when we're spreading that over 360 degrees, then we have 2 of them going at the 180 mark. Which is not quite right. It's not right at all. Which means we wouldn't want 360. We can fudge this by, I think, removing the last 90 degrees. So if I were to do that, I think this will make it look how we want it to. Yeah. So you got to do a little math with this to make it work right. Because this is each one of these is at the end of the arc. So if it's 360 degrees, the end of the arc is over here. No worries, Mai. No worries. There is no lateness here. In about half an hour, that's when we'd normally be starting the stream. So this is 5 to 70. I do have a Discord. It is, there is a link to it in the LinkTree in the description of the video, and I think there's one in the bio on Twitch. All right, so now we have these don't need a gate. Excuse me. Move in a random direction. That, and then oof. Wait 15. Then we are going to have a spread into 5, 2. Hey there, Where? We're doing okay. We're doing okay. Just about to run a weird test here. Should have little clusters of 3 appearing, but don't think random direction is playing properly with the spread of 3. That's... She doesn't want you to go there, Sherbet. Sherbet was attempting to cross past Ember, and while she was snoozing, she noticed and popped her head up, and her ears went half back, and he backed right off. Yeah. Ember doesn't have a lot of tolerance for Sherbet. Well, when she's napping, she has no tolerance for anybody. And right now, she's extra cranky. Let me show you. She's not fully displaying it, so Sky is in the top center there. That's Ember's spot. He will sometimes come over there and lay on her like a pillow. Maybe a bit of mutual grooming there, but she will not go over there if he's already there. So he has taken her spot. Normally, if that were the case, she would be loafed up. That is Ember's, I'm fine here, but I don't want to be here. I would rather be somewhere else pose. This is, she's kind of resigned to it. She normally doesn't sit there. But if she's not in her spot like this, she will be extra cranky to the other cats. So Ember drove Sherbet off, and Sherbet is thus on my headrest behind my head. Sammy and Mason there are completely absent of this drama. Especially during stream time, my cats are very chill. Ember is almost always napping where Sky currently is. All the time. But they will swing by for attention in their own way. They do, of course, play. They are cats. When Ember plays, it sounds like she's dying. Normally, she has this little trill voice. But if she's playing with something, it's like this yowl that she does while playing. Hello, Sherbet. Hello. He is ever so slowly getting used to the idea of walking near me and getting head pats and whatnot. Yeah, I know, bud. I know. Okay. I don't want to do this to test it more accurate. Let's just use a move to the right. That'll keep it. I'm not aware of any recent Godot drama. Nice. Like that. Mono game or STL2? Haven't tried any of that. I long ago poked Unity to see what it could do and how it worked. Never really liked the editor, and they have hence decided that they want everybody to hate them. They're trying to recover. But frankly, I would not trust them going forward. I won't be checking Discord until after the stream. And for the most part, I wouldn't use a friend's request, but you can talk in the server. I will look at a DM if it's there. Okay. Yeah, the spiral in a spread of 5 is going to look pretty different just in the way they operate. One of the big changes is that I'm coding in C#, and C# is, in my opinion, a pretty solid programming language. Very straightforward to use. All right, we have extra types of spread now. Hooray! Not what I planned on doing, but it's what we did. The game is much more stable where we can get 15,000 objects moving on screen in relatively complex ways. Let's see, what could we do? Okay, this is what we can do. In and all right, after 15, first the blobs are going to rotate out one at a time. So, single chain. After 15 seconds, they're going to split into 5 blobs. And they will start wobbling. Just so. And we can make that... should rotate inward, but that's probably part of the problem here. Let's make a weirder behavior. All right. For 15 seconds, they're going to rotate outward. Then at 15 seconds, they're going to start moving inward, wobbling back and forth in a group of 5. You can see about 4 blobs a second being spawned. So, pretty soon. Now they split into 5, and they're going to start trying to converge back to the center. Yep. And, I mean, we could grossly speed this up as far as how many you're seeing on screen by doing that. We can get them to be very far away by adding more motion like this. Yum. Remember, it's at about 60 blobs that you're going to start seeing them come back. So you can see this number will jump by 5 at a time now. It'll be 4 a second, and then periodically it will be about 5 a second in between. So you're seeing it jump up by usually about 6 at a time-ish. Now, in theory, they should start being able to make their way back here, but this outward force is messing them up. Direction. Stacking these should be okay, but I might have to use a movement continue. Continue in your proposed direction. Movement proposed direction just says keep going. There has to be movement that happened before it for it to do anything. What it amounts to is take everything up until now and add a little more to it. It can end up being a movement distorter in that way. Because they should be spiraling back in at this point. We're not seeing that. In theory, it might take them a little bit because these things will have moved a goodly distance off screen before the other blobs got here. We're going to speed it up. Random direction is not playing nice, I think, with the starburst. We'll have to look at that more closely. We should start to see it start to leap in units of 25 now. Still not fast enough. One of the things I need to add back in is collision and navigation and whatnot. We are very close to the point where I can get back into making some more of the gamey logic, like the player and the blobs as enemies again. should be coming back. Because I'm using move rotate in after that point. They should be converging here. Did I mess up for my test case? Should be homing back in on that. All right, 3-second wait. Yeah, see, that's working. Why it no do that otherwise? "15 seconds shouldn't be a problem." This should be here. And Yom. I think, yeah, there we go. Here they come. They're coming back. And they stop spawning now. Now all 15,000 of them will start to condense down into a spot in the center of the screen. Might take them a while because they're spiraling in but also moving in kind of a wave motion around that spiral. So it's another distorting force there. But you can see them starting to kind of whirl in the middle. But yeah, so what this system does, again, for those joining us and not having seen much of the rest of it, you know, all of the prior, like, 80 streams and what have you. This block always executes right from the beginning. In this case, when the blob first comes into existence, it's doing whatever is here. Right now, that's nothing. Then, after 0 seconds, it's important that we do it this way right now for the test. It starts moving very fast in this case, it's going to be to the right. So, 1, 2, do 10. So, about 10 times the width of a blob to the right. But just as it does that, like right once it comes into existence, you know, 1 physics frame later, 1/60th of a second, 25 of them will be created in a burst around it. So pretty much immediately. Now, these are all going to be trying to go to the right, but it will be distorted by this. So we're getting a bit of a weird pattern because it is a starburst that also, at the end of each one, is a starburst. Then after 3 seconds, each of the blobs there then starts to spiral in instead of moving out in a straight line. So you can see with this pattern, you can see the individual threads kind of converging again. Isn't that neat? Okay, Mason didn't manage to steal the air hockey puck. You can see him kind of just laying down right at the top center of the camera there. Nice. Okay, so we have all of this motion, and I think we're good on that front. So one of the things that we wanted to do was have movement that aims at the... If we can get the actual gameplay rolling again, the basic gameplay rolling again, including like the UI, we've got a lot of the pieces for kind of, pre-alpha gameplay. Still need to get the sprites bumped up to potentially 32 by 32. I think that's as far as we need to go. Which, coincidentally, would change the way that we zoom on it. We would change the zoom factor to 3. Which technically could reduce the precision of the movement, but I don't think you'll notice. Okay, but the thing that's missing for move to cursor is the ability to get a node. During movement, you look at a movement object, this is just a class. There's nothing about this that is a Godot node. Even an entity is not a Godot node. Now, the entity manager is, and we could pass information along to everything that says, this is the world, But I feel like having that universal pass in is sloppy. So I think having a static class that extends a node 2D that is loaded in as part of the game world would be a viable alternative. We could do it the same way with the entity manager if we needed to, but the entity manager doesn't really need space. What are we going to do? Okay, 1 second here. Get Godot going here. All right, Godot editor side. Just to show folks, this is our core scene right now. It has the game scene loaded as part of it. If you look at it, there is pretty much nothing there except for this color rectangle, a teeny tiny red dot that exists at the center of the screen to give me a point of reference as to what the actual center is. Then we have the game world, and the game world is our rendering thing, the thing that paints the blobs on the screen, our point of view, and then the frames per second and whatnot. Technically, this part could live out in the core layer. But it don't at the moment. So what I would propose here is to have a static node that exists inside here. So we are going to should still be okay. I don't even think it needs to be a node 2D. We're going to start with just a node. this be? Really is exceptionally tricky here. I think it needs to actually be a node 2D. We're going to find out, though. How are you going to be called? Going to attach a script, which will be screenhandler.cs. It inherits node. We're going to create that. Pop over here. So we have screen handler. Okay. So then move to namespace. So can't be static. That can't be static. All right, camera handler. Is it currently sitting? Camera handler, and it is going to be part of the view. That. Oh. Put it outside of the class. Yep, Godot there. Why is this not working? Oh. The editors were fighting with each other. Hey there, Art. I'm doing well today, doing well. I am located in the US. Or, if camera does not null. Cursor position. Okay, so then we have the concept of a camera handler. It just exists. Then at the start of the game, camera. Am I an artist? I mean, I do the art for the game, but I wouldn't consider myself one. You appreciate the compliment. The Vtuber model was made by Animation Studios. It's technically happening then. Then in our target cursor, camera handler, get cursor position. Many people make a living doing that, Art. Okay, so now we have cursor there. If we then go into catalog, and when we are loading targeters, part of the same group. Just one moment. I've been at this for a little bit, and I haven't taken my first break yet. So, be right back. And I'm back. Well, Art, as might be apparent, I am pretty well set for all of my stream assets at the moment. Emotes, all of that stuff. Target cursor. So then we need to go into our load movement. So this is moving to the cursor. It does not supply a location thing. That is something we could do, is to have a false entity that we could create. That is a risk surface creating a false entity, though. I don't really want to do that because there's a bunch of variables that could be out of position. But I could create a entity that is the I am the cursor entity. Move zigzag, we're going to take that. Move straight line. And it is a new target cursor. So then in our entity, not getting oh. But it's still getting 0, 0 though. Camera is null. camera is null at the point of... Oh, okay, this needs to be on ready. On ready. No, ready. Don't know if that's 100% safe, but we're doing it. Okay, well, it's doing a thing. It is clearly doing a thing. You can see... But... Okay, yeah. Because I'm setting the direction there. That's not right. Position dot direction 2. And now we have them tracking the cursor. Kind of neat. And to distort the chain by moving around like that. So this one doesn't obey rotation at the moment. I think there's an opportunity for that. But simultaneously, move to cursor is kind of an absolute. So we can showcase some of the weird that can happen here. We're rotating out as our base behavior. And then instantly, we're also going to start moving to the cursor. So we should get a bit of a drag happening. If you watch the edge of the circle, there's kind of a pull. So this is with move to cursor after. The movement of the spiral is being dragged towards the cursor. So now instead, we are going to take a rotate out, and we're going to put it here. Take the cursor, comment it out here, put this here. Okay, it's going to rotate out. It's going to move to the cursor, and then it's going to rotate out. See the difference in what's happening? The target position, the center of the vortex here, since it is moving to the cursor first. The center of the spiral is following the mouse cursor. The individual blobs aren't being dragged there. The whole vortex is being dragged there. And that neat. I feel like setting up some false entities is going to be a viable thing. We're going to have to see how I can do that, though. So then we're going to wait 15 seconds. Then it will burst and rotate in. But it will continue to be influenced by the cursor. Rotating out, influenced by the cursor position. And then at the tail end now, they've split into 5, and they are orbiting towards what they consider to be the origin position, which is 0, when they come into existence. But that origin position is then being dragged as well. Is giving us some very significant results here. Because once they're orbiting in, there's kind of a spiral effect, but they're also fighting an orbit out. So we are getting kind of this mass going. No, they're not fighting an orbit out. They're fighting the wave pattern. So then if we have moved the cursor back here, this moved cursor here, and we'll move it over to this. And we'll just block this whole bit off here. So instead of the move to cursor here, we're going to have got random direction first. And we will do we'll leave that as is. So they're moving out in a random direction. They are not affected by the cursor. At about 60 in the count here, the behavior is going to change on the outermost ones, though. you can see there's now a separate group that has formed that wants to go where the cursor is. Having an on-screen entity that represents the cursor wouldn't be a terrible thing either. It would potentially help with some of this. Again, a false entity. Which is part of the reason that I want to deal with the canvas or the render server. Man. Ember has tried to come over to Sky instead. She is, as far as the camera is concerned, above the camera. Sky has managed to drive her away. This is pretty neat. Let's see here. I'm gonna put the mouse cursor left center here. So we should start to see a clot form left center. Oh, Sky moved. Ember immediately went to reclaim her spot. Should have been getting that though, so it's move. Oh, okay, because it's always moving random direction. Mess that up. Does nothing by default, but what we need to have happen is this. So it immediately starts, but once this is over, it will only move in. It will cease to do a move random direction. And we can accelerate the scenario by doing this. Not that many. Yeah, that'll do. Actually, that's too much. You'll accelerate it by doing this. Okay, again, at 60 blobs, the second number, things are going to change pretty wildly. Because at 60 blobs, about 15 seconds have passed. See those little clusters forming? Okay, moving the cursor to the bottom left. Oh, wow. I haven't tanked frames per second this hard in a while. Okay, cursor movement has extra cost to it. Now, there's also the fact that I'm creating 125 of these suckers very fast. So we're going to see what happens when it caps out on entities. Okay, we may need to look at that because this might be a very expensive operation. This thing right here. Just a moment. This guy was starting stuff. So he had to be stopped. Okay. Okay, this is an internal clock. It does not need to be duplicated. Yeah, last update. Let's do this 0.5. Twice a second. So we've constrained how quickly we update this. What I might do is have the camera manager get an update every now and then so that nothing is actually pulling it. That would save us even more. Bit lower right. See, the mass is slowly drifting. The mass drifts at about 1 blob's width every second. Okay. So I want this to be something that... All right, this is what we're going to do. Now, I can have this updated as part of the master loop here. Static, double. Does it actually contain a private? Yeah, there we go. Yeah. It's greater than or equal to 0.5. Static vector 2 camera. By default, it's 0. Otherwise, if it's been at least half a second, mouse position is equal to get global mouse position. And in the game, during physics process, we're also going to do camera handler dot update. So now each individual targeter isn't doing it. It is just going to be one global handler that updates it each time. Hey there, Tass. Converging upper right. We'll let the remainder of the spreading ones begin the circle. I'll show you the pattern in a moment. All right, they're all orbiting in now. Going lower left. Here they go. The mass begins to move. Okay. Catalog. What we're looking at. By default, this group does nothing. After 0 seconds, it begins to move in a random direction. Then, after 15 seconds, it begins to move to the cursor, rotate in, and do a wave pattern. And it splits 125 times. Now, we can make this a little bit more exciting, I guess. And we're going to break this apart into 3 slices here. Okay, after 0 seconds, then we're going to do 3. So it's going to move in a random direction and split in 5. 3 seconds later, move in a random direction, split in 5. 3 later, random direction, split in 5. Then we can do a 3. After that, it's going to move to the cursor. It's going to rotate in towards its target, which currently is hard-coded to 0, 0. I might have a flag that I can put in that, but I don't think that would ever really have a utility. And then move as a wave. Split. Split. Converge inward. So now we can see the mass is going lower left. Now it'll move right middle. What for, Tess? Oh, do you mean like the, what the projectile does? Like, randomly construct this? That'll be a thing. That would be an interesting test, is, begin firing this and show it on screen. Hit a button to cycle to the next one, or automate the cycle. Like an old school Windows screensaver. Blobs, go! And now they will begin to coalesce. I want to make this more dramatic. You can see the orbital ones going just bonkers. Sure. So all these rotate ins were essentially just sort of like slingshotting them into oblivion. Once again, same pattern. 3 seconds burst, 3 seconds burst, 3 seconds burst. And then they're going to start heavily coalescing in the lower left corner. I've increased the drag towards the cursor substantially. It will cause them to overshoot the cursor a little bit by doing this. Yes. I've got proposed motion going, which would be the same thing. I also added logic to make it so that we're not pulling the screen position constantly. It updates twice a second. Okay. Now they're just about all gathered in the lower left of the screen. Now I'm going to quickly move the cursor to the upper right. They begin to converge. So if you look real closely, you can see they are overshooting because there's like a donut forming. Here, show you. I've moved it to the center of the screen. Once they finally get there, we're gonna see kind of like an eye of the storm form. See how it's they try to get to, but they can't quite reach the center. What's happening is that because it's moving at the cursor position, and whether we do multiple move to cursors or we do proposed motions after it, is its center position is constantly moving to where the cursor is. So that drag towards it is really heavy. But because it's being exaggerated, it overshoots in every direction. Oh, I love it. Collision needs to be a thing. I will need to... So it'll be a different test once we've got the blobs colliding again. That's one, and then we'll need to implement projectiles hitting the blobs. So the collision thing is a whole extra system. We also need to have another entity set up. Okay, so this is Blob. Blob, do this. We will do... We're going to have the Blob do part of this for now. So this is just our Blob entity. Should still work if I did everything right. Should. This is specifically player. We're going to use it differently, though. Then we go into our entity manager. And we're going to set up an A/B toggle here. Adding one entity at a time currently. Let's put this here. For reference, what you're seeing on all of these is their idle animation. Isn't that neat? Double check here. 300, they should start to converge. They are not. Oh, no, here they come. So one thing that you might notice is that the cat bots are always above the blobs. And this is one of the reasons that I want to look into the render server solution again and see if it can maintain performance. And that is because of the way that the mesh process works. Is the mesh can only have the one texture. I can get it to animate using shaders. And there might be some trickiness I could try to pull off with things like loading a different texture as a variable into the shader, but I wouldn't be able to do things like easily mess with the size of a sprite or similar, which would be a limiting factor. If I wanted to make like a sprite that was twice as big as normal while not just scaling it up. Also, it would mean one mesh handler for every sprite, and I want to see if I can clean that up further. But the player sprites are always on top because that mesh handler is created first. Because the player sprite is the first one in the catalog. That is the only reason why the catbot sprite is above all of the others. But yeah. Even just for giggles. Okay, so we have this entity. We are going to do... This is a temporary thing, which is not what we're supposed to be doing for this. This is not what we would actually do. Let's copy an entity. So we create a clone of it to do this. So then we only have to change all of this other stuff. There's a reason we'll do this. Nyanite, the blob, the wind-up mouse, and yarn. just want to make something really colorful. Oops. Here's the mouse. That is the yarn. And then an entity manager instead of this being an A/B toggle, this will be an integer, which is blob mouse yarn. Entity switch one or we're doing this because I think it will look neat. Mouse. So yeah. We're using all of our sprites now. And we don't have rotate to face. They're all doing just their idle and not their movement. They're not flipping to match their movement direction. All of that still needs to be resolved. But for the time being, we get neat animations going. And if you watch, you can see the precedence order of the sprites. What I'd still like to be able to pull off is Y sorting on them. But I don't know how much of a strain trying to do the alternate renderer will put on the frames per second. Hello, Sherbet. Hello, buddy. It's walking down me here. the center. So we have a couple of big undertakings facing us here. Canvas render is a whole other system for it. It is not out of the question to get this rolling, though. But I'd have to get some research done to actually make it viable. So what Canvas Renderer would entail is, one, extracting data out of each entity for let me look at the mesh render and show you what I'm ultimately dealing with. So on ready, it goes in and it creates an instance of a mesh renderer for each it creates an instance of a mesh renderer for each texture that exists in order that is in the catalog. Then each time for the entity list, we go over it and figure out which one we're dealing with here. Oh. So there's a lot of foot traffic going on in this. So we're going to go through and we're going to set up a list for every one of the meshes that we've got. And then in the entity manager for all of the entities, we go in and we say, okay, iterate over that whole thing and sort each entity based on its texture key into the associated bucket. Then for each one of those buckets, we're going to go through and we're going to take that mesh and we're going to update its list of instances based on what we've got. This is not ideal. This is C#, Cosmo. This is C#. We are using C# is our method of interacting with the Godot game development language. I'm simul-streaming to YouTube as well, Cosmo. So we've got... Yes. How do we want to do this? For each entity, we would need each entity to have some logic associated with it. So Osmo, my bio should contain a link tree that has links to all of my associated channels and what have you. Whenever we create a new entity, that would be an opportunity to, one, inform everything that a new entity has actually sprung into existence. So, for example, a rendering system. In the case of like a canvas renderer or even the mesh renderer, we could have there is now an entity in existence. When that entity comes into existence, anything that cares about an entity can then essentially take that entity and put it in its list. Similarly, when that entity goes away for any reason, it also sends an event that is remove this from your collections, which is an opportunity for things like the canvas renderer to say, okay, I don't care about this entity anymore. But the canvas renderer wouldn't actually care about entities. Whenever an entity comes into existence, the canvas renderer would create a visual representation of entity object. We are coding our game here, Cosmo. Let me show you. This is our debug logic here. It is a bullet heaven style game with very modular weapons. Right now, we're looking at some of the logical flow that can be done. This is, aside from alternating the sprites that I've got going, every one of these is being emitted as a single projectile that moves in a random direction. Shortly into its existence, it splits into 5. Then later in its existence, it will split into 5 again. And instead of moving in a random direction, it will start to try to converge towards the middle of the screen. This is all to demonstrate that the flow that we've got for these entities is functional. There is a setting, it's just not implemented in any way. Everything is in a gray void right now. But mechanics and all of that we already have kind of a spec sheet in a way. Is the drag that's happening here? It's the missing piece. So we should be getting a very strong inward force, but we're not getting that. Duplicate the entity. We should be getting all of this properly duplicated. Game engine is Godot. We're on Godot 4 or something now. Inward force is strangely limited. It's not like we're not seeing the orbit happen as cleanly. Because we're seeing the move to cursor have a definite effect here. We've given it an incredible amount of force there. Thanks for swinging through, Cosmo. No, the wave motion? I just noticed an idiosyncrasy in the behavior, and now I want to try to solve it. Well, thank you, Cosmo. Hopefully it will be a good coding session. So there's no wave motion in play, and they're all being told to move to the cursor, which is close to 0, 0. And they've been given a move straight line, which should be a steady inward pull. In fact, they have a severe inward pull right now. So they are slowly rotating, which is what the rotate in should be doing. But it's strange that the towards cursor is not having much of an effect. Because it is a very strong inward pull. They should be flying towards the center. Now we're seeing some erratic kind of jolting motion going on as they get close. Well, that's kind of strange. What's going on? And we wait 15 seconds. I had it spawn 5 to the 5th of them at once. So right now, the pull for go to cursor is 5 times stronger. Give or take. Now, the erratic motion once they get to the center is that the go to the cursor is times 5, and there's no boundary on it. Right now, go to cursor is before the orbit one. And it does matter. Since it's before the orbit one, the center of the orbit changes if I move. There, Laura. Let me make sure I didn't mess this up. Oh. We weren't actually constraining that, but we were still limiting how often it was called. And we wait 15 seconds. Doesn't actually have to be 15. Should change that for the purposes of this particular test. 3 seconds. How you doing, Laura? Start spinning. We had some good ones for that earlier. So I thought we just did this test to create that neat effect with the blobs, but... Okay, so now they're rotate in and they're dragged by the cursor. But they're not being dragged by the cursor. There's something not right in the copy logic, I think. Which is very weird. Because this force is substantially stronger. We can make it even stronger, but... Upper right. There is just the slightest of drag coming off of that. Something's wrong. This is bonkers force happening here. All right. Is the manager 1? So it considers this the center of the orbit. And there is... If there's a pull from our move to cursors, it's so subtle. So let's do... target cursor here. Target cursor. Oh. Well, we don't need to do this anymore. Camera handler, make sure that's correct. Yep. We can do it with just the one. That'll at least get it. Weird. There should at least be a distortion of it happening right now. Because this is just so much force being applied. It's like this isn't happening. Like this part clearly is. And this part clearly is. Am I missing something with the copy process on an entity that is throwing off the behavior group, the secondary behaviors? We copy each behavior, so whenever we copy one, if there's gates or similar, so we recreate behaviors when we spawn them. Overriding that there. Besides, this first one that we're spawning is a blob, which is the first instance here. So in our entity act here, since it's just going to spawn the one. Hey there, Blue. Huh. Got delta divided by 2 for some reason. How odd. Oh, okay. That's right, because I'm splitting the delta between each of the behavior groups, which isn't really what I want to be doing anymore. We'll fix that in a moment. So we break that gate. That is the first actual gate that begins the movement. So we look at the first one. Let's look at that entity. So gates now has 1. We removed the first gate. This is the one that we're acting upon. The first one is a behavior group which contains all of the move straight lines. So this is all move random direction and continue. Then we have the spread patterns there. Hey. Okay, no, this is the follow cursor. Right? Yeah. This is the active one. Yeah. And then the second one has a full behavior group. It's waiting the full 3 seconds. Then it has rotate and then a whole bunch of move to cursor. So run for 3 seconds. In a minute. Okay, no, that was a move straight line. Okay, so now we have its base action going on right now. So we have behaviors, we go in, we have no gates left, and we have a behavior that is active, final behavior in it. So in behaviors, we only have the one, which contains the only group there is, which contains our rotate in all of those. So if we are going to hop over to our move rotate, should give us a pretty substantial number there. Wait. Why is entity.target direction right? It should be fine, though. That should be fine. That's what's going wrong. Okay, 1 second. Direction is equal to this. This is cursor pull after. Okay. We could see a bit of a distortion happen there. So, right now you can see it's correcting down a bit. All right, so let's see if we can make it a little more visible. Hello there, Leah. Okay, see the lurch? Can be a little subtle, but there's a twitch. So that is with an intense cursor pull there. Let's pull even harder. Okay, that rotate is a very strong pull there. Let's change all of these directly to a move to cursor. I have an idea of what might be happening there. Because proposed motion in that case is merging those two. Yeah. This is a move to cursor force that is equal to the rotational force. And the move to cursor force is being applied after the rotational force here. So it can go in perfect opposition. Now we're going to take move to cursor and put it before the rotation, which will drag the center of the rotation. You can see the ones that are kind of wobbling in place are on top of what the rotation center is. They spread out as the rotation gets farther from them. So the more move to cursor I put here, the faster the center moves. Which in turn will change the way that the orbit happens. So the center is dragged really far away. And kind of spin it like pizza dough here. This much movement at once is still straining it. So with just the one motion. We are going to have to keep an eye on this, because we can see there that enough motions together really do distort it, or cost us a lot of frames per second. So this is with just one thing pulling the center. So the center still moves faster than the orbit can. So we're starting to see some of the rotations kind of wobble out of place as the center of the orbit gets away from them faster. And then if we want to make it even weirder, we put wave motion on it. What the wave motion will do is make it harder for it to converge on the center, essentially. So the rotation wants them to be in place, but the wave motion is twisting it. The working title of the game, Leah, is Nyanite Survivors. Both because that's what the little gray robots are, Nyanites, and the genre has become called Survivors, you know. Realism is a hard goal there, Core. Did Crisis teach us nothing? Okay, so that's fixed. Oof. Hello, Emperor. Hello, Emperor. Make it weirder. I just want to make it weirder. I feel like procrastinating. Because I do want to make and test the canvas renderer, but... Alright, now instead of wave motion, it's using a zigzag motion. So it kind of left, right, ticks 90 degrees as time passes. So even more so than with the wave motion, a smooth sine curve, kind of a cosine curve, but you know, that smooth, instead of a smooth curve, it's jagged edges. So it has a harder time getting to that center. You can see that jitter when they hit right on target and really want to move in. But the other motion fights it. Make it a little prettier doing this. Or at least a little more visually hectic. Because we have simultaneously the ones being emitted outward and the ones being pulled to the lower left at the moment. And then if we really want to get silly, for a second, so let's do 10 a second. Yum. A second. Yeah, 50. And then instead of random direction, we are going to fix that at right. Create a fixed pattern initially. So you can more clearly see the flow of kind of the center of this pattern converging up and right. It's where the cursor is. Now we're going to drag it down and right. If we finish it, that's the goal, Leah, is to put it on Steam. Wouldn't that be neat? And now down and left. I mean, if we can hold steady at 10,000 things with what we have planned to go on, and again, this is emitting 10 things a second. Well, it's emitting a thing every 10th of a second, and that thing is immediately splitting in 5. Okay, there's our 15,000 mark. Now we're going to do up and right. Lengthwise across the screen. Thanks. The two that we can see top to bottom are Mason and Sammy. That would throw a wrench into comprehension, wouldn't it? Like, people could probably be like, "Oh, you made video games, right? Oh, okay, that's like it's like programming, right?" You know, cutting out all of the other possibilities. Um, but you throw the VTuber in there, and that'd probably blow some circuits on some folks. At least initially. Then you'd start to explain it, and then you've got to hope and pray for comprehension there. Now, granted, there are enough people, it is becoming a pervasive thing. Like, people are starting to notice, but it's stuff like looking at the reactions of some of the folks when Gargura did sang at a baseball game. There was a lot of bemused confusion on some folks' parts. Or when people see the top of the like uh the women streamers charts, and at the top of it are folks like Iron Mouse. Like, why is there a cartoon character listed as the most popular female streamer? How long have I worked on this? This is technically stream 81 of working on this. I have started doing more work on it off stream, trying to keep that ramped up, keep more progress going. Our streams are generally about 3 hours long. This stream has been processing about 6 hours long at this point. No, like math. Stream stats. Have a number here somewhere. Okay, we started right there. 4.5 hours. I'd hope to start a little sooner, but it is what it is. It's kind of hypnotic, isn't it? Make this weirder. If okay. Rotates out, then it has double strength move to cursor and a rotate in. Cursor is currently lower left. So the rotate in and out should be effectively counteracting each other. But we should be getting a drag force, yeah. We get a bit of drag force from the move to cursor. So then double up the rotate in. Spread out. Hard rotate in. Oh, okay. This is moving the center. We don't want that moving the center if we want to see it converge. That's an... Move to cursor. Weird, that out is having a lot of impact. How'd I come up with the idea to make a game? It's something that I've wanted to do. I've poked at that kind of thing before, modding. I've looked at engines and kind of dabbled with concepts. Like I made a maze generator once. Still got the code laying around somewhere. I think we might have some convergence at the edges there. Do we? I think we're seeing it tighten towards the center now. But I finally decided, you know what? Let's try this. Let's try to make a game. I got up the motivation, downloaded Godot, and quite frankly, that's become what our stream is about now, is writing this. Okay, we are getting a bit of pull in there. Okay, no, but the rotate out is still messing with the rotate in. I didn't properly change it. And we're going to put the zigzag before the rotates. Trust me, the words I'm saying do matter as far as the engine is concerned. Well, that's doing a thing. The rotate out is really fighting hard. Actually, I think I know why. I don't think the rotate out is really compatible. So we're seeing even more distorted motion here because we're applying a straight line force towards the lower left, towards the cursor. But we're then applying zigzag to it, which is making a kind of a Z motion. And that's where the center is going. The center is constantly moving in that zigzag towards where the cursor is. So when I go up and right from down and left, look at that coiling mass there. That's a fun phrase, isn't it? Coiling mass. Then upper left. Lower left. Let's make this weirder. The point of the game eventually is going to be that the player is locked in the center of the camera, like your eyes follow the player, and monsters will spawn at the edge of the screen and converge on you, with you like firing projectiles out to try to stop the monsters from touching you. And the things that you're seeing here, the way the things move, and the way I'm explaining how to make them different, is how the weapons will work. Is you'll essentially have little things that you can combine. Okay, double zigzag isn't really... It's less apparent what's happening, but you can see the weird corkscrews going on here. Because it wants to move, but the way the zigzags work is practically pulling it back in on itself. So that was from lower left to upper left, from upper left to lower right. We can see it distort, but it has real trouble moving with a double zigzag. And with that in mind, what if triple? So, for those curious, when it starts moving, it is moving in a fast-moving spread of 5. Of a 5-point star with one of the points aiming straight right. In fact, let's aim it up so you can really see the star. Then after 3 seconds, it stops doing that, and instead it starts moving to wherever the mouse cursor is at about 2 times speed. Whereas when it is initially moving, it's about 5 times speed. Then it applies a zigzag pattern now 3 times. So it will rotate kind of off of center. It's rotating 45 degrees back and forth. Not smoothly. It's a hard tick back and forth. And we apply that 3 times. So in theory, the rightmost tick, because these are happening all at once, they are in sync with each other. The rightmost tick should be all the way over to 135 degrees, and then the other is negative 135. And then we have a double speed rotate in. So wherever the projectile thinks the center is, in this case, it starts at 0, 0, where the projectile came into existence. And it's getting dragged around based on that move to cursor in zigzag. So things get weird. Things get real weird. Effectively, it can't, with this layout, it cannot converge on target. It will actually move in the opposite direction more often than not. It's veering backwards left and right. So my cursor is lower left, but you can see they're kind of going up and right. That's where the knot is forming. So then if I move the cursor up there, we can see them start to pull away from where the cursor is. So we see the tangle go all the way back. Oh. Okay. If instead... And yes, I'm definitely dragging my feet from doing the canvas renderer. Yes, like HoloCure. That's the kind of game. So we have a zigzag, then a wave. A wave is a smooth curve between over time. It is a much like it's an S curve instead of a Z. Now we do get very similar. It's probably going to have trouble getting all the way to the lower left. But there are periods where it will line up. So we're getting the knot forming lower left now. Zigzag is much harsher on consecutive lineups. So then upper right. Not kind of unravels and keeps going. Wow. I kind of don't want to lose the way that it's coiling around. If I could get it where all of the projectiles were amongst each other, but could overlap this way so that we get this neat sort of like pseudo 3D look. Because if I get it to the canvas renderer can still could still do this kind of thing. But we'd have to make sure that it actually keeps that sequence. So I'd need some like other variable that tells like which order to render them in. Might still work, we'll have to see. Oh, we hit 15,000, so. Well, I'm looking forward to getting it done and seeing what we create. It's a journey. It's a journey. This giant tube of ropes spiraling down. Well, thank you, Leah. Any other kind of movement that we could throw in here to make it strange? Let's do S-curve. That's nice and smooth. Let's put in a random direction. Move to cursor will pull past it. Move to cursor is stronger than random direction in this equation. But we should get much more erratic movement from each individual set. Some of them will pull harder against where the move to cursor and rotate ins are going. Since the move to cursor is twice as strong as the random direction right now, it can't bring it to a halt. So it still will pull the knot in the direction that it wants it to go. But you can see that there's different amounts of drag happening. It's like we have multiple coils. Down center. In the lower left, that's 2 of my cats. Let's see who we can see. Okay, we've got all 5. We have Sky across from my keyboard, big fluffy gray and white one. Ember resentfully sitting to his right. She's the one with the orange ear. Mason and Sammy on the bed. Sammy's the black and white one on the big gray squishmallow there. And then Sherbet is over on the opposite wall from me, He is the kind of mottled tan and white one. Let's just do, just for visuals, we'll do just blobs and yarn. Because the nanites and the mice are kind of uniform darker colors. Yeah. Log. Add a third rotate in. So the inward pull towards the center is stronger now. So the inward pull, I think, is, yeah, there we go. It's strong enough, but it's got to fight much harder to pull the cables in. I like it. I like it. But I think that's enough procrastination for the day. Oh, I'm going to have to get some prep work done for the canvas renderer. Hopefully I will get that in there. We need that, and I also need to get some prep work done for collision handling and navigation. Because we need to start adding more systems that will drain the processor to see how many things we can have on screen at once. Because that will inform me at what pace the player can fire, that kind of thing. So checking the renderer and seeing if there's any performance cost to having a different one, if I can still hit 15,000 with one that gives me more precise control over how to render each thing, then I think we're in pretty good shape. If I can't, well, we'll have to fiddle with things some more. Ideally, I can still get the shader to attach to any sort of canvas handling, so I don't have to do any sort of math manipulation on each of the textures, each frame, that we can just dump that on the GPU still. But in the meantime, I hope everybody had a good time watching with us today. It is a lot of stream of consciousness, but I hope that you still have fun. If you like what you saw and would like to see more, remember to like, follow, subscribe, all of that stuff. I also have YouTube memberships, Patreon, and Coffee if you would like to consider supporting the channel. With all of that said, I hope the rest of your day is good, and I will see you next time.